Hello, welcome to STR8CHEM. In this video, we're going to learn about the electrolysis of concentrated sodium chloride, Aqueous, by using the inert electrodes. First of all, we need to know that the inert electrodes that we are going to be using in this discussion is carbon solid, or you can also use platinum electrodes. So this is the diagram of the electrolytic cell. You have the anode terminal over here, positive terminal, and the cathode terminal, which is the negative terminal immersed in the electrolytes that will be containing the charged ions. So we have the carbon solids electrodes, inert electrodes on both terminals. And you're going to have the electrolytes, Cl minus aqueous, sodium plus aqueous, and water liquids inside these electrolytes. At the anodes, you will have the chloride, Cl minus aqueous, and H2O liquid will be competing to be discharged at the anode terminal, whereas at the cathode, you will have the sodium plus aqueous and the water liquids to be competing to get discharged at the cathode. So the question now, which one of these two will get discharged first at the anode, and which one of these two species over here will get discharged first at the cathode? That is the thing that we need to be thinking about when we want to know the dischargement, the selective process at the electrodes. We need to know which one will getting discharged first at the anodes and at the cathode. And to do that, there are two factors that will be playing very important role. For the cathode, we're going to look at the standard reduction potential factor when it comes to concentrated sodium chloride aqueous, whereas at the anodes, we're going to look at the factor of concentration. So let's have a look at the cathode first. Like what we have talked about just now, for concentrated sodium chloride aqueous, at the cathodes, standard reduction potential factor will play the important role. So at the cathodes, the one that will be discharged first will be the water liquid. The reason is because when you look at the value over here, at the standard reduction potential value for water liquid, it is negative 0.83 volts, and the SRP value for sodium plus aqueous is negative 2.71 volts. And the SRP value for sodium plus aqueous is significantly higher or more electronegative than the electronegativity for water liquid. So that's the reason why H2O liquid will be selected first to be discharged at the cathode, because when you look at the E0 value or the SRP value, it is more positive. Therefore, water will be easier to be reduced at the cathode. On the other hand, for the anodes electrodes, the concentration factor will be playing the more important role. At the anodes, the one that will be discharged first will be the chlorine. Over here will be the chlorine gas first, because when you look at the E0 value for chlorine is positive 1.36 volts, and when you look at the E0 value for water right there, the E0 value is positive 1.23 volts. Supposedly, when you compare between these two values, water will be discharged first because it is less positive than the E0 value of the chlorine right there. But because of the high concentration, the chloride ions will be oxidized first if you want to compare with the water liquid. And at the anodes, the concentration plays a more determining role because of two things. The first one is because the difference in the SRP values is too small. When you look at the SRP value between chlorides and water, the difference over here is too small. If you compare there, the difference is so big. So that's why the effects of concentrated will not going to be affecting the SRP value factor. But right there, since the SRP values are not that too far away from one another, when you have concentrated sodium chlorides, the high concentration will cause the chlorine to be discharged first, and that is also because chloride ion, it has a higher rates of oxidation if you want to compare with the water liquid. So by combining both half reactions at the cathodes and anodes, you will have the cell reaction right here, and you will have the E naught cell value equals to negative 2.19 volts. Okay, so that's how you're going to be explaining the electrolysis of concentrated sodium chloride aqueous by using inert electrode.